Are you
Yeah.
interested in solving one more problem for our interview?
Yes, I'm interested. What choice do I have?
Well, you
Okay.
have many choices. You can go out and run like a madman on the streets, and
Oh,
you can run naked if you want. It's up to you. Or you can continue here with the interview. So,
yes, but I can run after the interview as well.
okay,
So
Okay.
that's not a
Okay.
choice.
So
let's
after
begin with the
a
interview.
lot of research for
Please,
your interview,
please
we have.
share the please share the problem. Don't waste my time.
Okay.
How
Now
harsh.
I'm sharing the problem.
Yeah,
Hope it's
thank.
readable to you.
Yes, it is visible.
And I think you should be less rude to the interviewer.
Yeah,
Yeah, okay, okay. Given an
I
array of
think
positive
I
integers
think you
nums,
should say sorry first before reading the problem itself.
please let me read, man. It's my interview. It's none of your interview. Given an array of positive integers nums, remove the smallest subarray, possibly empty. So we can remove one subarray such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Okay, so we should have at least one element. Return the length of the smallest subarray that you need to remove. Okay, we have to remove the smallest subarray.
yeah,
Cool. And return -1 if it is impossible. A
mm,
subarray is defined as contiguous block of elements in the array. So what we have positive integers. We have to remove at most one subarray, and sum should be a multiple of p.
exactly.
Okay, so we have these three things.
And after the
So
removal, you should be left with at least one element.
yes, yes. Okay. So what we can observe is if we have to remove at most one subarray. So suppose we are not removing any subarray, then this sum should be a multiple of p.
Yeah.
Yeah.
Okay, and suppose we are removing only one subarray.
Mm.
So it can be either a prefix like this, or it can be a suffix like this,
Mhm.
or it can be from the mid of the, I mean, from internally. It can be internal to this nums,
Yeah.
neither suffix or
Some
nor
contiguous block,
prefix.
which who where the end
Yeah, yeah, yeah. I got that.
collide with the starting index and the
Yes,
ending
man.
index.
Yes, it is the same thing I told.
Okay.
I
Okay, so
think this guy is quite aggressive.
Yes, he is. I have already marked -10.
Yes.
okay, okay. So suppose we are removing a prefix. If we are removing a prefix, the suffix sum should be a multiple of p. And likewise, if we are removing a prefix, the suffix should be a multiple of p, right?
Yes,
And
of course.
if we are removing this part,
Mhm.
then the remaining elements should be a multiple of p. And how can we check that? So suppose prefix till element I is the prefix sum till element I is prefix of I, and then we have to find a suffix such that suffix of j and mod p equals to 0. We have to do that, and it is from j for all j greater than I.
Yeah.
And since we have to remove the smallest element, we are interested in the smallest j
Mhm.
greater than I, right?
Yeah.
And how we can do that? So let's suppose we have how we can write this equation as prefix I mod p plus suffix j mod p, and let's take a mod of p here. And this should be actually equal to p, right?
Well, it can not in all the cases.
But if we have to find, we have to create this equation, we
Just
should make this
just coming
possible.
back to the point which you mentioned, this will not be equal to p in all the cases.
Yeah, but I'm checking for all non multiples.
I'm talking about this equation.
We have to
Like
find the
this
nearest
sum,
j.
this sum might be satisfying our condition, but it is not necessary that the sum should be equal to p. Like you are, because you're also taking the mod here.
Yes, so this thing is going to be less than p, and this is also going to be less than p, and we have to make sure that the sum is equal to p, and only in that case it will result to 0.
Well, both of them can also be zero. Then ultimately,
Yeah, man, I initially told that I'm checking for all
yes, I
zero odds.
yes, but I'm just talking about a particular equation. Go ahead. Yeah, it does not matter.
Did you understand what I just said?
Yes, I understood what you just said, but you said that this sum would be equal to p, and then in reply to your statement, I said
Yeah,
this will not be equal to p in all the cases, as this term can be zero as well, and
yeah,
this.
that's because yeah,
So you
that's
can say
because
this should be a multiple of p. So
you
this
are
can
just
also be zero.
you are just killing my time, man. Okay,
Okay.
so let's say
I
okay,
think we should not continue this interview further after such words
since
spoken by this
Hmm.
interviewee.
since you are stupid, let me rewrite this equation. So
Since
suppose
we
we
are
get
okay,
we let's find prefix of I mod p, okay, then we have to find the nearest j greater than I, okay, such that, are you following along,
yeah,
such that
you have already said all these things.
such that
You are just repeating yourself.
suffix of j mod p is equal to, what is equal to, p minus this thing.
Yeah.
So if this equation is wrong, why this equation is right? Yeah, you are very stupid. I don't like interviewing with stupid interviewers.
Suppose this term is zero. All
I
right.
initially said that I am checking it for only the what you say, only non-zero mods.
You said it.
Yes, I said
No,
it.
no. You
Well,
didn't say.
to be honest, I did not hear that part, but okay.
Okay, I will.
We might have missed it, so you can continue.
Okay, I will repeat that part in the video. Okay, so you can see that.
Okay.
Okay, so So in order to find the nearest j, we need to maintain all the mods. So can you tell me what is the range of numbers?
Yeah, the array elements can be up to 10 raised to the power 5, and no, the array elements can be up to 10 raised to the power 9, as well as the value of p.
Yeah, okay. Okay. So what we need to do is we need to maintain a list of all numbers having a particular mod.
Okay.
And we cannot do that because there can be 10 raised to power 9 possible values. So what we need is we need to maintain a map of vectors so that we are not, because that matrix is going to be very sparse,
Yeah,
and then we can just find if that element exists or not,
yeah,
and
and
then we have to minimize that answer.
that is pick the smallest j you can.
Oh, that is flawless.
Let's
So
see, we'll see about that.
what are we waiting for? Why don't you give me the function signature?
We were just waiting you to ask us for the function signature. Now you have asked it. Here is your function signature.
Okay, so let's write the include so we don't get any unnecessary errors.
Yeah,
All right. So what we need is we need a map of vectors. So we need a map of vectors, and we need to store them at some integer key. And let's name it as remainders. Okay.
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 And now we need to check. So let's have answer equals to -1, and let's return the answer here. I'll be calculating the answer now. For int I equals to 0, I less than. So let's create some suffix. Uh, should we do that? So if we have to create the suffix, then we'll be inserting the element at the back. So it will be in decreasing order.
Yeah,
And I'm not sure if we can apply upper bound function on decreasing vectors or it is only possible on increasing ones. So what else we can do? If we are inserting at the front, we will not be using vector.
yeah.
So I think we can
What about the other way around?
other way around.
Like we move from right to left and we look at the prefix. And when you be looking
Oh
at the
yeah, we can do that. Okay. So instead of suffix, we can maintain prefix and okay. So that's a clever idea. I did not expect that from you, man.
yeah, shit happens.
I less than num start size I plus plus, and then what we have to do is we have to find the remainder of. So let's maintain a prefix. So int prefix equals to 0, and prefix plus equals to nums I, and we have to take the mod equals to p,
Yeah.
and prefix of, so this is the mod, and we have to insert an element at this position, and what we have to push I.
All right.
And what we can do is we can check if remainder dot find prefix is not equals to remainder dot, and we can directly push the element, else we have to create an element. So remainder prefix equals to vector of int of size 1 having a value prefix.
Okay.
And now we have to move from backwards towards the front.
Yeah.
And let's say if prefix becomes equal to 0. So if we have prefix equals to 0,
Mm.
then we can have the answer. If answer equals to -1, that means answer has not been found yet, or answer is answer is greater than the nums dot size minus I,
Okay.
then answer equals to I plus 1. So let's check if this condition is right. So if we have three elements and we have first element equals to 0, then we want the answer as 2. So I is 0, so we also need to subtract 1 here. Oh, alright, so answer is num start size minus I plus 1.
Yeah. Wait. Suppose you are at the last index,
Mhm.
right? Then have you and you have found that prefix equal to 0. That moment you would be calculating it as 2, but you are deleting 0 elements. I think it should be nums dot size minus I minus 1.
Yeah, I wrote wrong here, but I wrote right correctly here.
Oh, yeah.
So sorry for that. So
Mm.
now we have to move from backwards towards the front.
Okay.
For int I equals to nums dot size minus 1, I greater than equal to 0, I minus minus. Now we need a suffix. So int suffix equals to 0 and suffix plus equals to nums of I, and in the same way if so suffix mod equals to p, okay, and if suffix equals to 0, then we have to update the answer. If answer equals to -1 or answer is greater than, so what are we removing? We are removing the prefix now.
Left part.
So if we are at the last index, we are removing nums, we are removing I elements.
Yeah.
So we are removing I elements. So answer equals to I.
Okay.
And and now what we have to do? We have to find the required prefix.
Yeah.
So int required equals to okay, let's have else here, or okay, so int required equals to p minus suffix. So this much is required now.
What was that?
If so, we have to check into map.
Yeah.
If remainder of this remainder exists, dot we have to find the upper bound, the first element smaller than the current element. So we have to find the
No, no.
first
Now you are going in the uh, reverse direction. So you need to find the largest index, such index which is smaller than j.
yes, I'm saying that we have to find the small element just smaller than
Yeah.
uh,
Okay.
I.
Okay.
So what we can do is we can find the first element greater than equal to I, and we'll check if one element on its left exists or not. So for that we can have int lower. So let's have the iterator first. So we are having lower bound of remainder of, so required dot begin comma remainder of required dot end. And what we have to find the first element less than equal to greater than equal to I. So if itr okay, so
It will give us the
we
element
have
at the right of current element, right? Okay.
the first element greater than equal to.
Okay. Okay.
Okay, so on the left element on the left of this element is guaranteed to be smaller.
Okay. Okay. Fine.
Okay, so now it might happen that we do not have this
Mm-hmm.
vector. So if remainder dot find required equals to remainder dot end, then we can't do anything. So we can just continue.
Okay.
And now we have found the first element greater than equal to I.
Yeah.
Now we have to find the previous of this element. If itr is not equals to remainder of required dot begin, then itr equals to previous of itr.
Okay.
Okay, and now we can just remove this subarray.
Mm-hmm.
If answer is If answer is greater than, or let's say if answer equals to -1 or answer is greater than. So what we need to remove? We need to remove all elements from I minus 1 to this ITR. So I minus 1 minus star of ITR plus 1. So we can just remove these things because they will be cancelled out. And now we need to update the answer.
Well,
And
suppose your value inside ITR is equal to 5 and value in I is equal to 8, let's say. Then
mhm.
if you minus this, it will give us 3. But actually, you are removing the in between elements, element between these indexes, which are only 2, I guess, 6.
Yes, so we have to remove, okay, so we don't have to include ITR. We have -1 as well.
Yeah.
Yes, so I think this should work.
Yes, yes, I guess so. Yes, the solution will work. And this tell us the time complexity of your solution.
So for time complexity, we are just, in this part, we are just adding all the elements. So if map is designed to work in order of 1,
Mm-hmm.
then this is going to be order of n, this first part.
Okay.
But since it might not be possible to work in log in order of one time, it will be at most order of n log n time. And here we are doing the same thing. We are moving to all the elements and then we are finding the lower bound.
Mm-hmm.
So it will take log n time, and yes, the complexity is going to be n log n.
Okay. And just to make sure for our viewers, so in this third part, we are deleting the part uh, in between the index ITR and index I. So we are deleting this part. Am I right, CPD?
Yes, you are right. We are not removing these two elements. So that's why we need to do -1 as well.
Okay. Yeah, that's fine. You did well as expected. As far as my feedback is concerned, the only thing, and I guess it is an important thing, is you are very harsh to the interviewers. So I'm complaining to the HR right now, and I'll try to make him fire you.
Yeah, he
Okay.
was very rude.
Sorry.
I think you should be a little polite.
Yeah.
Sorry, sir. I will keep that in mind. Please
Now
give
you're
me
saying
job.
only because your job is done, as you know that you have done a good job in the interview. That's why you're saying such things. So do you have any feedback?
Sorry, sir.
See, I don't want to talk to this guy.
Yes, he was very rude, and at least you should type a little bit slower so that you are not getting many of the spelling errors, mistypes. Be a little slower. Nobody is going anywhere. We are here just to hire you. But as you are very rude to us, so I am not decided what to say to the HR about you.
Okay,
So
sir. So
I'll
you have decided to not move forward with my
No,
application.
no,
eh,
you are selected for the next round. That's a different
next
story.
round. Yes, but I
Okay,
will
thank
definitely
you.
talk to HR that do some personality development of this boy.
Yeah,
Okay,
we'll
sorry,
arrange
sir.
such sessions
Yeah,
for
we'll
you.
arrange such sessions for you.
Sorry, sir. Please don't tell HR.
We'll see. We'll
No,
see.
no, I have taken the screenshot of all the stuff which you are doing.
Sir, HR is my ex. She will fire me. She's looking for
Okay,
revenge.
we did not know about this thing. Now we'll surely tell her. Okay, CP
Sir,
Rick B,
please.
you did well, and it was nice having you here in Tarun Networks. So,
Yeah,
Yeah.
thank you.
meet you in the second round. That's all for this video. And yeah, let's end it. Tata, sayonara.
Sayonara. Sayonara 2.
Sayonara 3.